Was it good? Did I do it this time? Awesome.
This time. All right. Good afternoon, GitOpsians. Sorry, we're a couple minutes behind today. I think that's us a lot lately, but big celebration because Christian nailed the intro stuff.
Yes,
So,
finally.
finally.
Eight times the charm, or whatever they say. Exactly.
Yeah, whatever that ended up being. So that's very exciting. Almost as exciting as our guests. So we don't actually have any other announcements today. We're going to jump straight into all the things. So joining us here today from across the aisle over at IBM is Bryant and Dan. I am not attempting your last name, Bryant. We didn't discuss that before, and I'm not doing it now.
It's like, is that equivalent? Is that like to across the cubicle, I guess, on the other side of the building?
Yeah.
Or from IBM for sure.
Anyway, so they join us from zSystems, and they are specifically working on Ansible with zSystems. And with that, I'm going to hand it over to Dan. I think we said Dan, right? Yes? We're going to hand it over to Dan and let Dan finish off this introduction.
Awesome. Thank you. And hi, everyone. Thanks for joining today. My name is Dan Jast. I am one of the product managers here at IBM covering our Ansible for IBM zSystems initiatives here. It's been a really exciting last 3 years of working in this space. And we're really excited to, share with the audience here with the GitOps Guide of the Galaxy what we've been doing over the last 3 years and, talk Ansible. It's been a really fun time. I'll pass it off to Brian. You want to talk about yourself and pronounce your last name, Brian?
Yeah. I'll make sure to pronounce that for everyone. So my name is Bryant Panyarachun. I'm the chief architect for the Ansible for ZOS ecosystem. So, leading the technical side and, everything that we're contributing into the Ansible space, enabling ZOS and all that automation goodness.
So I got so before kind of you guys drop in, I know a lot of folks have done a lot with x86 systems, x86 64 systems, and I guess not getting too technical. It's kind of hard to get too technical, like describe kind of like what zSystems are. Can you give like very, very high level overview? At least for me, right? At least I don't know if anyone else on the chat. I'm going to be selfish here. If you could give us kind of like overview about zSystems.
Absolutely. Yeah. So zSystems, if zSystems is kind of the IBM terminology for what our product suite is here, right? You've probably heard of zSystems as a mainframe before. That's kind of the more common terminology that is used in the enterprise. But when you think about what a zSystem is and what a mainframe is, I always like to relate it back to, servers that are driving lots and lots of transactions. So in most cases, a lot of people don't even realize how much every day they're interacting with their mainframe. Every time you swipe your credit card, or every time you book an airline, use, your insurance, anything like that is actually behind the scenes, working against our transaction processors that are running on the mainframe. I think in 95% of major transactions happening worldwide, actually those transactions in some point or another are coming through a mainframe. So really, really big servers, as I saw, Mr. Callahan just put out in chat. It's great. It's really, really powerful systems. Brian, you want to add anything there?
Yeah, and actually, before I do that, I kind of wanted to throw a question back at you guys here. And what is the first thing that you think about when you think about mainframe? Like, what is the impression that you have with your current understanding?
Oh, that's not fair. I have a very good understanding right now because I have a friend in the office of the CISO over there at IBM. So I'm going to zip it because I know things.
Okay, maybe I don't know the Christian.
Yeah. Well, I don't mind being the ignorant one because I actually don't know. So I imagine like room-sized computers, right? Like room-sized big, talking about like threads, maybe, we're talking, most people thinking about x86 64 about like, oh, I have, 128 threads, 256 threads. Like we're talking like a ton of threads, right? Like maybe even in the thousands, I'm assuming, right? Like maybe like really, really big machines, big threads, big lanes, lots of lanes and big lanes, right? Like if we make the freeway analogy, not only just a lot of lanes, but big lanes as well, right? You're fitting a lot of data there. So that is kind of like my understanding of a mainframe, right? Kind of like a room way in another building doing all these transactions, like just insane amount of transactions.
Yeah, no, I mean, you're absolutely right. I mean, I think the general sentiment really aligns with, at least the ability to support all of that throughput of transactions. It used to be that size as well, not so much anymore. More recently, the mainframes, a common, view more, has been like that they're, the size of refrigerators and they're kind of shrinking down. They're actually like this half of a refrigerator now in most cases, for at least the flagship,
And they use less power than a refrigerator too, don't they?
They do. Yes, there's a lot that's been going on from the sustainability perspective and, ensuring that we're using, lower power consumption there. But also more recently with Z16, this is the introduction of rack mount as well. So not being able to leverage all the different types of rack and server types of storage and fitting in, all the different types of storage that our customers have as well, and that new form factor. So that's a big deal from the hardware perspective, the new rack mount.
So I'm going to geek out a little bit on the things that I know before we start diving into how Ansible plays into this. So the things that I know that I've heard over from other colleagues is not just about the power thing, but one, that ZOS is open source and has always been.
Mm-hmm.
Two, that it's backwards compatible for apps that have been built for it all the way back to its inception in 1969?
Mm-hmm.
And three, that it is so attuned to the hardware that it actually directs the electricity as needed. And that's part of what makes it efficient.
Nice.
It's kind of like capacity on demand. When you buy a mainframe from IBM, there's a lot more than actually what you're purchasing installed in your box. And you're basically just turning on different features. So you're turning on X terabytes of memory, X processors when you need them. And then with certain demands, let's say Black Friday, right, when we talk about really high transaction rates and stuff like that, you could up those rates and different pieces of hardware to be able to satisfy the requests coming in. So it's pretty impressive what's happening behind the scenes. I like to compare it sometimes to my gaming PC, where I was super excited to upgrade from 16 gigabytes of memory to 32 at one point. And we're talking about, I think the two boxes ago, I think had 40 terabytes of memory just alone. So yeah. It's ridiculous.
Anytime we talk about like large capacity of memory, this reminds me of a joke. So I don't know if you know this. In Windows Vista, you could tell it that hard drives were memory. And I always now I always have the very pithy of, okay, but can I convince it that storage is memory? Is it that flexible?
Yeah.
Yeah. Oftentimes, what I like to compare the mainframe to as well is I don't know if you guys are fans of F1, but I see it as an F1 car, right? It's an extremely high performant, highly specialized vehicle that takes a highly skilled set of engineers to be able to operate against and are specialized in various facets of that vehicle tuning, right? You have a suspension guy, you have a tire guy, a drivetrain and engine, right? And there's a whole lot of performance and capability built into every aspect, and that's exactly how the mainframe is as well.
So I was gonna say we have a question in.
Yeah,
in the
I was gonna say
this
very
is such
interesting question.
I actually have a perspective on this as well, but I'll let you folks answer and see if our information agrees.
Yeah, I wonder also if this is a common misconception coming from like the x86-64 world to like mainframes, because it's like it's almost like a paradigm shift that you have to do with your mind coming from like the X, right? Because like that would be this would be my question, right? Coming from the x86-64 world, it's like I wonder how all this stuff differs, but like I'll let the experts answer this, because yeah, I'm curious myself.
And for those who are for any reason unable to see what's on the screen, I'm going to read the question. So is it a good idea to have a single powerful giant server? It could be a single point of failure. How do you overcome this challenge?
Yeah, so I mean, I'll kick it off and I'll pass it to you, Brian, to get into it more. But IBM guarantees a very high level of availability with the mainframe. I believe right now it's 7 nines of availability, if I'm not mistaken, which comes down to about, I think, 3 seconds per year or something like that we're talking around downtime. And we're not even really talking about downtime because there's so much failover built into the way the system operates. So really, in most cases, when we talk to clients, there's really no downtime that they've, in most cases, ever experienced for their production environments or their production level applications. It's pretty impressive.
And
yeah, no, absolutely. I mean, really, that's one of the key, you know, value propositions of the mainframe is that resiliency over, you know, multiple layers of redundancy for every single component. We're not talking just hardware, the operating system and all of our software as well, right? You have multiple layers where you have multiple backup batteries, multiple CPUs, IO components, you know, cryptography modules, multiple layers, and dedicated, you know, channels for all those things to really, you know, help against that, you know, resiliency.
but your backups have backups have backups. Your failovers have failovers have failovers. And also I think that's a very brilliant usage of the resources, but the fact that they've able to make, like, the mainframe has been evolving this whole time, right? It's one of those things in the shadows. Stephen mentioned that he thinks of mainframes, he thinks of COBOL. Like, yeah, that's still running on mainframes, absolutely, but they've gotten smaller. They've gotten, we talked about this, more energy efficient. You have backup batteries. Well, your backup batteries can last you, especially on that low of a power draw, until backup generators turn on, and all these types of places that are going to have a mainframe, really, they're also going to have backup power, all those other, all their additional failovers. So the mainframe doesn't need to do all of the failover lift, but the fact that it's so efficient allows it to do so much of that until the generators kick on, the power is restored, what have you, and so forth.
And in some of the testing, I personally used to work in Poughkeepsie, where the manufacturing plant for the mainframe is, and some of the testing that they go through there is incredible. They have these, you know, environmental chambers they put the mainframes in, where they vibrate them, they drop the temperature super low, they bump the temperature super high. I even heard at one point a mainframe fell over on its side and was continuing to drive the applications that was running in it. So, I mean, it's unbelievable. If you ever have a chance to go to Poughkeepsie, I really highly suggest getting a tour of the manufacturing plant. It's amazing what's going on in there.
So they're doing literal crash testing.
Big time.
That's fantastic. This is adorable. We have, like, this insane amount.
Really cool. Yeah, we just got raided, which is cool. Linux tips. Hello. Thank you very much for the raid. Actually, I believe this is our first raid or second raid. The first raid came from, I think, the IBM developer Twitch stream. So hello, guys. Thank you for the raid. Appreciate it.
It's adorable. The internet is such a place. Okay. This will make it entertaining to follow the comments thread. So folks who have us on Slack, if you want to ask questions in Slack, go ahead and do that. I'll watch my Slack. I don't usually. And so that's it. Let's actually start maybe getting to the Ansible portion of the show.
Awesome.
Yeah. Like I have so many questions about like Z and mainframes, but you know what? Like let's stick to actually like the topic, because we can spend like a whole hour talking about mainframes, right?
And our audience is very chatty. I'm going to call you out on having not actually watched this stream too much before coming on, so you won't have noticed that our audience is very chatty and talks a lot and asks a lot of questions. Not always on topic. There could be entire other conversations happening in our chat while we are on topic. And so yeah, anyway, we'll just let them do their things and interrupt you as need be. So we all know I love Ansible. I talk about that a lot. If you've ever tuned into a single episode of the stream, you've probably heard me say that. Christian knows I love Ansible. He likes to give me grief over that sometimes. Yes. So tell us why you love Ansible.
Yeah, I mean, first of all, you know, Bryant had kind of hit on it a little bit earlier, where working, you know, this incredible system, which is the mainframe, comes with a very specialized set of skills as well, right? When you talk about working on the mainframe, you talk about some of the technologies that we're working with on a daily basis, you haven't heard about those on Linux. It's a very different set of focus there. So, you know, I think Bryant had, you know, maybe something prepared here where we could give you an example of what this sounds like in a day-to-day conversation of what working on the mainframe and even maybe a very basic task is. So Bryant, go ahead.
Yeah, I mean, more commonly, like a user will, have a JCL with a couple of job steps, execing an IEF BR14 and maybe another exec with the IB copy, with like a copy and a select statement, copying some of the desired members. You know, and you guys follow that, right? I mean, that's fairly straightforward.
We know that sounded like nothing to most of the people that are probably listening to this right now. But Brian, why don't you tell them what
I mean,
probably
essentially what that's describing is, you know, leveraging some mainframe specific tools really just to create a directory and copy a file to something, right? But, you know, as with everything being so specialized on the platform, you've got tools that are very specialized that, you know, kind of are constrained against, you know, historical constraints in terms of naming, right? And there's a lot of proprietary different technologies in terms of scripting and languages with JCL and how you use, you know, control statements and things like that. And it's not necessarily the most intuitive thing as a new person coming into the platform. So that was really one of the things that, you know, why I loved Ansible and when I started looking at it, because I was doing some automation early on in my development career, you know, against ZOS products and within the mainframe, and seeing that, well, I'm having to learn all of this unique stuff, and why can't I, you know, use some of this other technology that I'm looking for, you know, when I'm searching on Stack Overflow or Red, and I see, you know, people using all this other automation tools, but I can't leverage that against any of our, you know, ZOS utilities or anything like that. So that's where, you know, really started diving in and seeing what can we do, what are the gaps, and what can we develop to really to expose the mainframe to more of these more open automation tools.
Yeah. And that's
You know what's
go ahead.
Yeah, so I kind of wanted to point out with WD Callahan, the only thing I don't like about Ansible is that I didn't have it earlier in my life. That's like very, very true, especially for me. So in case you didn't know, Hillary and I used to work together before Red Hat. And in case you didn't know, we used a combination of Puppet and Chef. We had like this abstraction layer over it, which was really, and this is kind of like the difference between infrastructure as software and infrastructure as code. And back then, like, you know, we didn't really have infrastructure as code per se. We had more of like the Puppet and Chef, who was very app centric and very like what it takes to get this app running on a system point of view versus managing a system, right? Which is kind of like where I think, and this is kind of like if Ansible was around, I would have just totally used Ansible back then, because, you know, we had to use kind of this weird combination of like Puppet, Chef, shell scripts, wrote this abstraction layer. It was really, it worked for the time. Wasn't my favorite thing. Really wish we had Ansible, but that's kind of, you know, WD Callahan. I'm there with you.
Yeah, I was gonna say, and not only that, like this was the job where, it was. We had various, like we had an integration environment, we had a staging environment, we had the production environment, we had a holding environment. And holding was the previous version of production. And the way you promoted to production was actually just point the DNS to staging and then recycle the other set, like the previous holding, right? And so that whole, when he says we had all the, that was what he was doing with this whole everything, right? And then for the actual like integration deployment, we had Jenkins jobs.
Mm-hmm.
But we didn't like, it wasn't just like a Jenkins job. This was, you know, back in ye old days of yore, we had daisy chained Jenkins jobs to do so much of this for us. And so that was like, I had a lot of that, like, I interacted with the Jenkins jobs, fortunately, because of where I sat versus having to deal with his whole Puppet Chef thing. But it worked. It worked. It was one of the best orchestrated rollout processes of both servers and code that I interacted with. Even well after that, until I'd say microservice architecture became the norm.
Mm-hmm. Yeah, and that makes complete sense. And I think that what you're hitting on is kind of your experience as a developer and what you're able to do from a deployment standpoint there, right? And that's really what we're going after for the mainframe, is that experience. Because when you talk about some of the automation languages that have existed for the mainframe for the last 40, 60 years now, we're talking Rex, we're talking JCL, things that most people that are probably listening have never heard of, one, and two, in most cases are not being taught in college, right? So there's an inherited skills challenge in working with this platform here, where we're really trying to, and the two words I throw around a lot are providing a standard and consistent experience coming from other platforms or coming in from college where you can apply your Python skills, or if you're learning Ansible on other platforms, just writing that same YAML playbook code and being able to automate on the mainframe, right? And just being able to take that, same tooling, work with it on the mainframe. And that's really what's happening, not only in the Ansible space that we support, but across really the entire, mainframe software portfolio strategy, is that standardization and consistency.
Now, if I'm remembering correctly, and I shame on me for not double checking this ahead of time, I think you all have published some of your playbooks, have you not?
Yeah, we've published quite a bit of our playbooks out on GitHub. So we have a repository. We unofficially named our sample playbook repository, but we've got now, Dan, over like 150 sample playbooks there, highlighting
165, I think, the last I counted.
Nice. Yeah. So plenty of stuff there highlighting a number of different use cases, very basic things, all the way up to more advanced things, provisioning different software, on ZOS, and showing how you can use all the different modules as well.
So is it a build? So again, I'll be the ignorant one. I'm not afraid to ask dumb questions. Is this a build of Ansible running on like a zSystem, or is it like RHEL running on zSystem that happens to have a package, an Ansible package? Because it needs to be compiled, right? I imagine like there's, it's a different CPU architecture. It needs to be recompiled. So you're talking about like RHEL on Z, or are you talking about like, I guess you said ZOS, and there's a build of Ansible available for that operating system?
Yeah, no, that's a great question. Actually, Ansible today doesn't run on the S390 architecture in a supported way. Now, there are definitely people who are rebuilding Ansible, recompiling it to run, like in a Docker container on Linux on Z. That's available as well. But again, and especially with like things like AWX too. But when we're talking Ansible automation platform, things like that, and getting service and support, that's not technically a supported route, but it does work there. But, our strategy and what we've been working with a lot of clients really is, getting clients comfortable as well, leveraging off-platform Ansible, right? Leveraging an x86 environment and managing, their zSystems environments. Because I think that's one of the other challenges with the mainframe community is the idea and very much being used to being in silos, right? All of the mainframe folks are siloed off from their distributed folks, and all the tools, all their automation, all their processes, all are owned and governed by those mainframe teams and live within the mainframe platform. And this is a very much new paradigm where are some challenges in some cases, but we're also seeing a lot of success with our customers too, who are really embracing that and are working closely with their x86 partners. And now they actually are onboarding with some of their existing Ansible infrastructure, and the teams are managing that. So they actually don't even need to know how to deploy Ansible, have to manage those environments. They're just getting straight to writing playbooks and saying, this is what we need, go deploy it on your existing automation controller, and give us access to that, and we'll go from there.
What I find really cool about that, and I guess it's worth mentioning about Ansible, because Ansible is really for better, I guess you can make an argument either like it is or it isn't, but it's kind of agentless if you think about it, right? Mm-hmm. And agentless meaning it uses SSH, so technically running SSH is the agent, but really I guess SSH and maybe a couple of Python libraries is really like just the bare minimum to have like a client out there, right? So then I guess what you're kind of explaining is are you explaining kind of like a mixed architecture where kind of like maybe like the Ansible, like you say, like the AWX instance, right? It may be running on x86-64, and the clients are, right, like some of these big mainframes, zSystems.
Yeah, exactly. Yeah, you would access your zSystems in the same way as any other system, right? Over SSH or over REST. So some of the collections that we have in our offering actually is called the Red Hat Ansible Certified Content for IBM Z offering. I know it's a little wordy there.
We love these names, I guess, both at IBM and at Red Hat, right?
Yeah,
like just give it a ridiculous name. Let's just do it. We lean into it. We
should not be allowed to name things. We really should not be allowed to name things. I say this as somebody who this week heard like 4 times, yeah, this thing was great, but the name was terrible. And I'm like, yeah, but see, I work at Red Hat, and you know that I belong here because I'm also bad at naming things.
Yeah, just to give you a feel, though, for how different this mainframe space is in a way, too, right? When you say SSH, that's probably something that's so common and so, been used for so long in the distributed space, right? We have clients that are enabling SSH on their systems for the first times here to be able to work with Ansible, right? This is where we're talking that there's a paradigm shift that we're seeing in the ability to work with systems the same way as they would on the distributed side of the house.
And if I understand it correctly, and I think I saw this on the website, the hybrid cloud with mainframes is becoming a thing. That's becoming a standard architectural model as we move into, what is this? This increasingly complicated global economy, global data economy, even as well. Because part of the reason one of the drivers for that, I believe, is actually also the fact that you have the data sovereignty laws. So some of these places have been piping all of their data through one mainframe in somewhere, someplace, right? And now with data sovereignty laws, they can't do that. But they don't want to lose everything they have already going. That's a good thing on the mainframe. So I think that's one of the reasons why we're starting to see a hybrid mainframe cloud architecture model. And I think Ansible, you can correct me if I'm wrong, Ansible really is like not the way, but that's a big power to it, is you can use that as a vehicle to make those happen and keep those things uniform. You using it in a GitOps way.
Yeah, no, that's absolutely right. I mean, Ansible fits perfectly within that hybrid cloud strategy and that ecosystem and deployment, model that we're seeing a lot of customers go forward with as well. Obviously, with Ansible being able to automate against all those different cloud platforms, AWS, GCP, Azure, and zSystems, and then also actually be deployed on all of those things as well. That's another option.
It's really I think what do you call it, a switchblade knife, or kind of like a Swiss knife, right, sort of thing, where you have kind of like this automation. I was going back before with the different architectures. I mean, I include ARM in that as well, right? Like, it's just like you have this, you're managing your mainframe, you're managing, your x86-64, your ARM architecture. Ansible also have support for things like networking equipment, right? Like they can log into like your Cisco switches and start making updates and getting those. There's F5, for your load balancers. Like there's a module for that. There's a module for like Windows as well. Like, it really has become kind of like a lingua franca, right, for like sysadmins, and really kind of like the go-to for like some more of like the cloud native sort of like workflows, right? We here at the stream we feature Argo a lot, right? But and we concentrate on cloud native infrastructure. But there's like that's like really only a small part of like your entire organization, right? You may have to manage other things that is maybe not so cloud native. And it really is, Ansible really kind of fits nicely there, right? Because it's like a common framework to work kind of with all your devices. So it's really, really, really nice to be able to do that.
Yeah, and you're hitting at one of our biggest entry points here, because in most cases, right, Ansible's already running in our clients' shops, just not on the mainframe side of the house. So they've already recognized the value that Ansible can bring their business. They have use cases that have been proven for great use cases for Ansible. And now with the content that mine and Brian's teams are being able to provide to the Ansible community, you're basically just extending the value that you've already recognized now to the mainframe as well, right? It's a pretty cool experience that we're starting to see. It's awesome.
So we've talked about the good. I'm going to skip the bad. Tell me about the ugly. What are some of the hardest things you've had to solve? Whether that's a people, a process, a technology kind of an aspect. What's the ugly about this? Because we know it's good. We're here because we know it's good. So tell us a little bit about the ugly.
Yeah, I think the best place to start with the ugly is probably the perception of open source software on the mainframe. That's been something that people have been very hesitant to bring there, because the mainframe for so long has been the most secure place. And how could we bring in this open source software that we don't know what's going to be happening in our systems or this and that, or making those connections to those open systems versus having everything within the box, right? So being able to convince, customers to consider, connecting to their distributed based Ansible automation platform environment in the beginning was a huge challenge for us. We've ultimately come up with a pretty good story there about the benefits of being onboarded onto that existing Ansible architecture that's, standing up, that's been stood up already, and allows kind of the mainframe side of the house to focus on playbook development and source control management of their playbooks, and not have to focus on installing Ansible Tower or Ansible automation platform and managing all the role-based access controls that come along with that, of distributing that automation across the enterprise, right? So from my perspective, that large umbrella of just that understanding of open source software and connecting to open systems is the hurdle that we're honestly still working towards getting past with some people in our client shops.
Yeah, honestly, that was the first one that came to mind as well. Kind of touching on a little bit of what I talked about around the cultural aspects of things, right? The silos that some clients, want to continue to kind of keep, ownership of, right? And kind of keep their teams like within these silos, and being really comfortable around, starting to leverage more open software, more open tools, right? And actually trusting some of the new skills as well from the other platforms, or their new tenure folks who actually are more familiar with some of this stuff. Because again, the mainframe platform is highly specialized and takes years and years of experience, right, to really be comfortable, be productive, and understand the inner workings of the system. And for someone to be able to come in and leverage a tool like Ansible and be immediately productive, right? That's a completely new type of paradigm, right? That, again, is something that, is a challenge sometimes when it comes to, the current workforce.
What's the most, so what I'm interested in, right? Like, all right, cool, like you guys are using Ansible, and there's customers using it, which is like on zSystems, which is amazing. Just thinking in my head how much this piece of software has grown. What's the most unique thing you've seen being automated? And when I mean unique, I mean like specific to zSystems, right? Because there's like, I mean, you can do all kinds of crazy stuff, right? But like, is there something like or maybe like a problem unique to zSystems that kind of like Ansible was involved in, helping? I'm shooting off the cuff here, so
I'll say that you can share might be the other half of that too. That you can share, right?
Yeah.
I will say, I also am curious when we after you think about that, I'd love to talk more about OpenShift on Z, which is also a thing.
Absolutely. Yeah, I mean, the use case I'm thinking of in my head is software maintenance on the mainframe is a very, very special. You mean Bryant are thinking the same way.
That's the exact same one I'm thinking about.
But software maintenance is very specialized on the mainframe. It's called the tool or technology that we refer to there is called SMPE. It's a very involved process of receiving, the software, applying the software, checking it. There's a lot of steps. I believe it's like 7 or 8 steps in just doing a very simple, upgrade to a piece of software. That in itself, I was a system programmer about, 5 years ago when I started at IBM, and I had no interest in getting involved in software maintenance because it was that complex. It was ridiculously complex, and I knew that it was going to take me at least 2 years in the role to be able to confidently do that on a production level system. Being able to automate each one of those steps with Ansible and provide that in some sort of self-service manner for someone new like me to be able to just basically fill in a data set name or fill in a software name to go and pull that from the repository or the golden image that someone else is managing would be huge. And that's where we see a lot of clients looking at is automating that software management lifecycle. Of being able to not only drive the updating and upgrading of software, but then the verification that software has been upgraded successfully on the systems as well. That I'd say is, the more specialized Z use case, because a lot of the use cases we talk with clients are use cases that Ansibles are used for all over the place. And it's really just now we're providing the connection into ZOS to be able to do that in our space as well.
Yeah, that's one thing actually. Again, another paradigm shift and another thing about like patching and upgrading like zSystems is, I mean, we on the other side of the fence take, we take advantage of things like DNF or apt, even things like RPM and Debian packages. Like that stuff is easy, right? Like I used to manage Solaris systems, and like even on the Spark, right? Like it's not so easy to do patching. Now like everyone's spoiled, right? Like on the x86-64 system, they do DNF update, or you do apt-get, whatever your flavor is. Even easier now on Kubernetes, where you just pull a new image. That's another paradigm shift. It's like, oh yeah, updates. Like I just took it for granted. Like on Ansible and x86 system, just say upgrade this package, but like never really occurred to me that it is a little bit more complex on a mainframe, right? Like it was complex on a Spark system. Like me thinking back, I would imagine it's like probably exponentially more complicated like on a Z system.
Yeah, and just to give a little bit more insight into kind of what it looks like with SMPE, that one of the differences here is that products are shipped not as one all-encompassing binary package. It's shipped basically as a library of a bunch of different modules that you install. And then when you're actually installing with SMP, there's different zones. So you have like your distribution libraries and your target libraries that basically make a copy of your runtime of your product that you're installing. And then when you apply updates to that, you basically get something what's called like a PTF, which I think is program temporary fix. But that's like an update of a small subset of your library. So you get different modules that have actually been updated. So you're doing an incremental update. You're not ever installing the entire package. So you can imagine over a period of time, you're going to have a bunch of these PTFs with a number of different module updates. And then imagine rolling that out to 100 of different instances across hundreds of other LPARs, right? And that can get really messy really quickly.
Yeah, I remember like updating Spark systems. Like I'm just making this analogy because it's probably very similar. Because like you would download the patch, and then like, oh, the system would tell you can't install this patch because you need this patch. So you go to that patch. Like, well, you can't install this patch because you need this other patch. And then you try to install that other patch, and you're like, well, it's incompatible with your system. And I was like, okay, well, you need to patch your kernel, which then like it's like you get this like really weird and like, oh, have you installed that? Boss would be like, you installed that patch yet to the systems? It's like, well, I'm still trying to. 3 weeks later, I'm still trying to like figure out like which set of patches is the magic, thing. So, some of the things that we kind of take for granted nowadays on the x86-64 systems, where it's like DNFY update. All right, cool. Like, go to lunch.
Well,
Right, sort of thing.
You'll be happy to know this, Christian, because I think 5-6 years ago we actually brought Spark to ZOS, so you can.
Oh, there you go. Yeah.
You can run Spark on ZOS now.
I'm not sure if that's better or worse. I've never worked with Spark, so I'm like,
Yeah, I was gonna say like, so now I can relive my nightmares.
I don't know. And compounding nightmares here, I think.
Yeah.
So yeah, okay. If I'm trying to be slightly mindful of time, and we're at a little under 40 minutes right now. So I really, really want to talk about these OpenShift playbooks I'm seeing in this GitHub repo. Let's talk about OpenShift and mainframes.
Awesome. Yeah, I mean, so first of all, I think from an OpenShift perspective, there's a couple different layers we're looking at there. One is the actual setup of OpenShift, right? I think that's a very common use case off platform as well, where you're automating the setup of OpenShift with Ansible. And that's definitely what we're looking at on the mainframe side as well to help the install process. I think I honestly did that 3 years ago before I took this role in Ansible land as a system programmer, installing one of the first demo OpenShift systems for our technical sales communities there with an Ansible playbook that was provided from the OpenShift and Z development team back in the day. So that was a pretty cool thing to be able to do back then on Linux on Z. I think the other side of it is really being able to work with Ansible operators and being able to provide self-service type of approaches for developers to be able to drive tasks via these Ansible operators via OpenShift. No matter really where you're logging into this OpenShift environment from, you have these tasks available at hand to be able to drive. I know that's what Bryant has kind of been driving as a part of one of our other offerings at IBM. Providing these operators to be able to provision, software, languages, middleware on ZOS.
Yeah. So yeah, to Dan's point, we've talked a lot. We've done a lot of work around sort of our base Ansible strategy, right, and providing Ansible collections and content for that. But yeah, Red Hat OpenShift is a huge part of our hybrid cloud strategy and our cloud native developer experience with IBM Z, and that's where we have that IBM Z and Cloud Modernization Stack offering with a particular component of that called the ZOS Cloud Broker, which really allows you to surface existing resources on ZOS within OpenShift. And how that works is that's all with Ansible kind of providing all the underpinnings and interactions with ZOS. So they're providing a framework as well to take Ansible playbooks and use what's called this operator collection spec as part of the ZOS Cloud Broker. And once you import that, you package it as an Ansible collection, but you import it into the ZOS Cloud Broker, and that'll actually create an Ansible operator in OpenShift that manages your ZOS resources. Right, so
that's really cool.
That is
that's
completely
awesome.
new paradigm that we're introducing with that.
You know how much I love Ansible operators, Christian.
Oh yeah. We did a presentation on it. We did
a presentation on it.
You did several presentations on it.
We're gonna have to watch that.
Yeah.
No, this is one of those things, you probably know this, I'm preaching to the choir here, right? The Kubernetes operator, like the SDK, is that is Ansible, right? That's Ansible under the hood. So you can have a Golang operator, or you can have an Ansible operator, you can have a Helm operator, you can have, I think I saw there's Java operators is another one in the work, right? You can have whatever flavor of that you want at its various levels of capabilities. But it's because it is Ansible under the hood, right? You just get so much of that basically for free with the Ansible operators. Like I know we talked about this in our emails, and I could not find it when I went to go look for it again, but the process to go from Ansible playbooks to an Ansible operator.
There's a migration. I know what you're talking about. There's essentially like, there's like a migration thing. It's like, here's my playbook,
migration thing, yeah.
And it turns it into an operator. Like, you don't even have to write the operator. Like, it'll just spit out the code for you.
Or there was, when I went looking for it again, I couldn't find it. I know I sent you all something along that, though, that should simplify it. But at least there was. It probably still exists. It just got moved, and I didn't know where to find it. So somebody from the Ansible group, if you know where that went, tell us. We want it. But anyway, so the fact that you're using Ansible operators is just like current me looking at past me, looking at the audiences who were there in the past and going, see, I told you so. So let's talk about OpenShift a little bit more. Because technically speaking, we are, I'm wearing even the OpenShift shirt. We are an OpenShift stream. So I think this goes back to the same. We talked about the hybrid cloud strategies with mainframes in the past, right? And I imagine OpenShift is involved for a lot of those architectures. Are you seeing OpenShift on mainframes not as part of hybrid cloud strategies at all? Are there other things being done over there that you can talk about?
I think that's a good question. I think more recently we're looking at more integration with some of the bigger hyperscalers out there as well. I think that's an angle that you'll start seeing coming from IBM pretty soon here. Taking advantage of some of the maybe source control libraries that they're using over there. Specifically we work with a major bank who all of their Ansible playbooks are actually hosted in Azure repositories, and now it kind of is a nice, that's some of the power of Ansible too, right? Is that now we're able to have Azure collections that are driving Azure processes matched up with the ZOS playbooks that are, driving ZOS processes. And it's kind of this hybrid cloud landscape that we're just generally creating right there through Ansible as well. But yeah, I think the hyperscaler stuff is probably what I'd go to. What about you, Bryant?
Yeah, no, that's what I was thinking about as well. I think OpenShift very much is a part of many of our mainframe customers' hybrid cloud strategy because, again, it is, for us from the IBM perspective, a key piece in what we're providing from the cloud native developer experience, right? That really is, our solution. It's centralizing around OpenShift and all of our other platform tools. I talked about the ZEOS Cloud Broker, but that's really only one of the very, many other components that we have in that offering, and being able to leverage that with OpenShift and also, be able to deploy that. So it is available as a self-managed service, within AWS. And we're working on other cloud platforms as well. But, I think it is really a key piece for any of our mainframe customers in the hybrid cloud.
And some of the cloud native development side of that too is built upon like the Red Hat Code Ready Workspace type of technology that you could host within within OpenShift as well. So.
Yeah, so I'll touch on some of the other components, right? We have this whole WASI suite of tools, which, Code Ready Workspaces is part of that. WASI Sandbox, which provides the ability to deploy containerized ZOS environments as well in OpenShift, right? So you can actually deploy a virtualized ZOS and use that as a dev test sandbox. We have a number of analysis tools, right? Being able to analyze your applications and, be able to see all the different dependencies, API tools as well, API toolkit with ZOS Connect to be able to API enable some of your applications.
And this is important, right? Because we're talking about COBOL with mainframe applications, which is, we're talking at a whole the same back to 30 minutes ago of all the challenges on ZOS, right? Yeah. So being able to analyze and understand that COBOL code, which is not the easiest thing to do for a lot of people out there today.
I would say that's huge, right? To be able to spin up virtual instances to test COBOL code. To me that just blows my mind, right? Like that's just we take we take some of the stuff for granted, right? In some of the x86, kind of from that point of view, but COBOL is so old, and there's stuff running out there that's still running on some of this code, and to be able to what's your test system? It's to be able to do that rapidly, right? Before, I don't even know how that headed.
I know how it worked. My father-in-law was a COBOL engineer, and he has stories for days. We should just bring him on sometime to let him tell us all about the COBOL programming. But
that's an awesome.
Specifically, he has this great story about going back out of retirement for contracting for the Y2K stuff, and having to expand the date fields from a 2-digit to a 4-digit. And he's telling me, he's like, it wasn't that we couldn't do it at the time. It was that never in our wildest dreams did we think this stuff would still be running.
Yes. Yeah.
They did not think they thought it would go and fall into obscurity by then. And so that is why I always tell people, don't think that never plan for your software to be rewritten. It's probably not going to happen, but it will be refactored.
Yeah, well, and I think it goes to, it's indicative of how much, kind of to your point, Hillary, how much of the stuff is still out there in production and still running things. It's I always, I see, people sometimes the OpenShift on Z, that's kind of weird. OpenShift, why are they deploying some of these newer kind of technologies on some of these older stacks? And it's because we're still using it. There's again, also I can imagine, not just in financial, but I imagine in financial kind of situations, where banks need to do these transactions ultra quickly, right? If you think about some of the stuff you're paying, for things using your phone, those transactions go really quick. They show up almost immediately on your bank thing. Some of these transactions have to go really, really, really fast. And I imagine NASDAQ also needs super, super fast transaction. And so, some of this stuff is there's nothing else that does it faster. So why would we migrate off of it? Right.
And smaller, right? They were working with such restricted computational resources when this stuff was developed. And what's going to have a smaller footprint and use the hardware more efficiently than the oldest stuff? Mm-hmm. Not a lot.
Absolutely. And about 2.5, 3 years ago now, when some of the election stuff was going on, COBOL was going viral because some of those some of those applications to drive some of that, was maybe not, being perceived as working correctly. And COBOL went completely viral at that point, which, definitely wasn't COBOL's fault. And I think IBM sent some pretty good messages about that at the time. But, I think so. Like when I cut off Bryant there, I'm sorry about that, Bryant. And he was getting into the API strategy and kind of hitting on your point, Christian. For this stuff that's been used forever now, that's where it's really, really cool, because now what we're doing is we're taking some of those components of those applications that have been in production for 40, 60 years, and we're front ending that with an API. So then we can leverage some more, more modern application frameworks and more modern GUIs, more modern languages to be able to call those services into that backend COBOL that's been, trusted and, running in production for all that time.
By the way, quick piece of career advice. COBOL engineers still get paid very well. Still a relevant skill. Every now and again, my father-in-law still gets a call and it's like, hey, are you? And he's like, no, I'm retired. He's an instructor at De Anza Community College, and he's very happy with that. He'd be quite content to never program in COBOL again. But that is not a disappearing skill. That is still highly sought after. So all those occasional early career people who watch the stream, learn some COBOL.
Yeah. Also, I would imagine quite lucrative as yes. Those people are retiring and so it's for sure.
And there's a lot of resources out there available now. Again, sometimes mainframe has that sort of perception that it's inaccessible and there's not a whole lot of information around it, or at least to learn, which is true to a certain extent. But more recently, there's been a lot of effort around curating more programs and resources and things like that. And IBM Z Explorer is one of those, right? Where it used to be formerly known as Master the Mainframe. It was a competition, but now it's just a readily available resource where people can go and learn all sorts of stuff about the mainframe and get access to environments as well, and kind of go through this course to be able to get actually hands-on and learn a whole lot there. And then I know there's a whole lot of other programs for colleges like Marist as well. Dan knows a lot about that as well. But a lot of folks who are involved really building up this community around education and skills, and really cultivating sort of the next generation of folks who are coming to the platform.
Well, I am more inspired to learn mainframe stuff than I ever was before. And I have all that free time to do this in, so of course it's it's just going to be the highest priority. Thank you, Christian, for making the Chad joke, because it really occurred to me too. So
I see Hillary just dropped a link too in chat to Z Explorer. I'm aware of people that have went through Master the Mainframe and Z Explorer there and gotten jobs just based off of the basic level of training for the mainframe, because those skills are so specialized that you learn as a part of that training program. I also believe there are awards along the way as you get through the different levels of that training, that they'll send you like a cool IBM backpack or, some cool IBM swag. So just a little incentivization to maybe go check out that program in the process.
Oh my gosh. I have, you guys wouldn't know this. Maybe even most of the stream watchers wouldn't know this. I have a Red Hat sponsors a nonprofit community called Women in Software Engineering with a nonprofit called the WIT Network, where we teach women how to do things like pass coding interviews, do general code mentorship. I actually literally have a coding coach coffee hour next week that I didn't have an agenda for yet. And guess what is my new agenda? This is my new agenda for so thank you for solving that problem for me.
Very nice.
I get asked all the time. People reach out to me on LinkedIn. I get asked all the time. I'm early career. I'm struggling. What can I do to differentiate my application? So thank you for this. I will be now telling them this. We have 5-ish minutes left. What did we not get to that you wanted to make sure to say while you were here today?
Well, I think that something that we can talk about quickly is, Red Hat's doing a great job enhancing the Ansible automation platform as a whole, right? And as new features come out for the Ansible automation platform, we're trying to be, right behind them and being able to extend those features for ZOS and the mainframe, right? So there's some really exciting announcements that had recently come out, I believe at the last Red Hat Summit. At other conferences around this, idea of project wisdom, and it's a new initiative in the Red Hat Ansible space, where basically we're looking at now a joint effort between IBM Research and Red Hat to take our AI training models and machine learning capabilities, bring that to Ansible, where you're able to in VS Code write in plain text, hey, I want to provision a transaction server that connects to my databases of a DB2 and this and that, right? And based off of the training that the models have gone through, it's going to be able to populate a playbook, not only with the modules that you want to build out there for your automation, but also ingesting the system-specific information to fill in the variables it needs to. So we're looking at a super cool, future with Ansible here, not only from that perspective, but also helping our mainframe community get started and adopt this technology by being able to, take advantage of those, auto completion type of capabilities there. And Bryant's the one, leading the charge there.
Yeah, I mean, generative AI, that's such a hot topic nowadays, and it's just super exciting. Again, I've been able to work with, some of the early wisdom models and do a little bit of training of that with some of our Z collections, and it's just super exciting for me to be able to say, copy a data set to blah, 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 and it automatically populates all of our modules for ZOS with the correct parameters, right? And understand some of the context within the playbooks, and it just makes it so much easier. And that's where I'm really excited, just to not only for the usage with ZOS, just Ansible in general, right? Mm-hmm. It makes it so much easier. It was already pretty easy, I'll have to admit, to write Ansible playbooks, I think, but making it even easier with generative AI, that's just so cool.
So are you working with Richard, Bryant?
Richard
is he's one of my peers. He is the I think the primary software architect for Project Wisdom here at Red Hat.
Okay, I'm not working with him directly. I'm working with some other folks, but
probably indirectly. Yeah. I should totally just introduce you guys at some point, just for fun. I think you would like him a lot. We are hitting top of the hour.
Yeah, I can't wait till Project Wisdom then starts using the quantum computer that IBM has, and then we'll all be out of a job at that point. So we're just it'll be like Wall-E. We'll just be in chairs drinking smoothies. So it'll be awesome.
That's fine. I can sit in a chair and drink a smoothie all day. There are a lot worse things that you could ask me to do.
Yeah, they're still going to need some smiling faces like us to come and talk about this stuff, right? So.
Yeah, exactly.
That's true too. But can I do it with a smoothie?
Smoothie is it?
Yes, smoothies make everything better. So
yeah, exactly.
Yeah, it really does, right? Because smoothies everything better. Okay, we are at time. Thank you, both of you, so much for coming. This was one of our most trafficked streams. I was watching the numbers go through, and we had over 86 people watching at a certain point.
Awesome.
So that was obviously a topic people were excited about. We'll keep in touch, maybe have you guys come back about something sometime, or just so that more people can nerd out about mainframes, since it was a very, very exciting topic. And thank you again also for the resources. You definitely made, I think, a lot of people who are watching feel like that mainframe is approachable. And I'm going to be cribbing from your playbooks as I try to learn. Yeah, I did that. I made that joke. As I tried to learn my way through some of that stuff as well.
Awesome. And if you're checking out that zExplore program in your women's group there, Hillary, you'll actually be able to play around with our content there, because it's in there as well. You get to use Ansible as a part of the zExplore program. So nice.
All of my favorite things coming together in one place. That's a good day for me. All right. I have a really hard stop, so I have to force Christian to end the stream. Thank you guys so much. We really appreciate you. You can follow both Bryant and Jast, or Daniel Jast. Sorry, I read your last name first. I'm the worst. Follow them both on LinkedIn. And I think it never doesn't apply. As always, choose your technical debt wisely, folks, and we'll see you back here in 2 weeks.
Thanks, everyone. Thanks for having us.